Hello, welcome to Physics Lesson 2.07, Horizontal Kinematics, Part 1. I'm Mrs. Baumgartner. And in this part, we're going to explain where the equations come from and a little bit about kinematics. In the second part, we're going to do sample problems. So if we get to the end of this and then we haven't done sample problems, don't panic, they're in Part 2. Well, let's start off talking about the definition of kinematic. What does kinematic even mean? Kinematic is the study of motion, ignoring what started or stopped the motion. So let's define kinematic. Study of motion with no regard for the origin or end. We don't care what got it going. We don't care how it's going to end. We only care what's happening while it's in motion. And one of the requirements is that you have to have constant acceleration. So if you didn't have constant acceleration, you know how we started off with when we have acceleration on our displacement time graph, we have a parabola, then we go to a straight line, then we go to a horizontal line. If you don't have constant acceleration, that won't happen. So for all of these, you must have constant acceleration. And that's why problems will say with uniform motion, constant acceleration, so on and so forth. There are four, we call them kinematic equations. And these really are foundational. They let us study 5 different variables: time, initial velocity, final velocity, acceleration, and displacement. So we've been talking about these individually. These 4 equations tie them all together. And guys, this is the same physics they used to put a man on the moon back in the 60s. If they're going to put somebody on Mars, these are the equations of motion. Doesn't matter if it's a planet, doesn't matter if it's an atom or if it's well, I have to be careful because when we get down to atoms, they get a little sketchy. But if you get down to, a single-celled organism, these apply. And the good news is you already know the first equation. So equation number 1 we saw when we did VT graphs, and it is, we're going to rearrange it a little bit. But this is the y equals mx plus b of the VT graph, except our y is final velocity, our slope is acceleration, the horizontal is time. And instead of writing y equals mx plus b, they always put, it would be the same as saying y equals b plus mx. It's the way it goes, and that's equation number 1. Equation number 2, I'm going to leave a blank spot over here. And what we're going to do is we're going to derive this equation, and I'm going to work on this over here on this side of the paper. So to derive this equation, we're going to start with equation A, which you've already seen. Remember back in 2.02 or 2.03 when I asked you to find an equation of motion for an xt graph? We had this. I have to tweak this for you a little bit. It turns out that this is average velocity, and to find average velocity, we take v sub o plus v sub f and we divide that by 2. So I'm going to rewrite this equation as x sub f equals x sub o, and I'm going to write 1/2 because I like nice, neat lines, v sub o plus v sub f t. All I did was I took this and I popped that in for that. So this is equation A, and equation B is going to be v sub f equals v sub o plus at. I'm going to give you an assignment, and I'm going to have you pause the video and take a crack at this. And what I want you to do is to derive an equation in terms of x sub f and eliminating v sub f. This is similar to that question on your pretest where I asked you to manipulate an equation. I gave you a bunch of, I just threw a bunch of letters together into a formula and I said, put it in terms of P or put it in terms of Q. And it also incorporates substituting equations. Can you put two equations together to come up with a new one? Now, I will tell you, if you know for 100% sure you're not taking the AP physics test, this won't be that big of a deal for you if you can't do this. But over and over again on the physics test, they'll say, derive an equation, and they'll give you a situation. They might give you things you've never heard of before, and you have to look at the relationship and you have to come up with an equation that fits. So a lot of what we're doing here in physics isn't figuring out what the answer is in algebra. We're understanding how these things relate to each other. Okay, so go ahead and pause the video. And once you're done with that, then we will move on. Okay, how'd you do? Did you get an answer? All right, well, if I want to get rid of v sub f, I can do that. I have an equation over here that has v sub f in it. So what I'm going to do is I'm going to take this whole expression, I'm going to pop that in to that location. And that's going to give me this formula. So I still have my x sub f equals x sub o plus 1/2 v sub o, but now instead of v sub f, I have v sub o plus at. From here, guys, it's just algebra. So I'm going to leave this part of the equation. We don't really have to do anything with that. I'm just going to work on this expression in the middle, if that's okay with you. So I'm going to have 1/2. These parentheses basically go away, and I'm going to end up with 2 v sub o plus at times t. And when I factor in the 1/2 and I factor in the t, this is going to make the 2 go away. I'm going to multiply that by t, so I'm going to have v sub o t. This is going to be 1/2 at squared. I'll bring back these terms. So it turns out that my second kinematic equation is this. X sub f equals x sub o plus v sub o t plus 1/2 at squared. My third one I'm just going to give to you because the derivation's a little more, it's above our pay grade. It's the final velocity squared equals the initial velocity squared plus 2 times acceleration x sub f minus x sub o. And remember, this can be written as delta x. And you'll often see it that way. You'll see x sub f minus x sub o written as delta x. The fourth one we don't use all that often. We say that delta x, or x sub f minus x sub o, equals 1/2 v sub o plus v sub f times time. And that comes from average velocity. So we could say the average velocity, taking the 2 and divided by 2, is equal to the change in distance over the change in time, and they just brought time over here to that side. Now you'll notice that the first equation, what variable is it missing? Take a look at this. There is no displacement here, no x. Take a look at equation number 2. What are we missing? There is no v sub f. Take a look at equation number 3. What are we missing? There's no time. And this guy, there is no acceleration. That means that if I have 3 kinematic variables, I can always solve for a fourth. Or if I have, acceleration, final velocity, and initial velocity, and I want to solve for displacement, well, I have to use this guy because there's no time. And in the next video, I'm going to show you how to use these. You might say, hold on. What about if I don't have an initial velocity? You don't run into that very often, but I'm going to kind of just give you this kind of on the side. This can be written, equation 2 can be rewritten a couple times in the homework. I think you might see this where you can rewrite equation 2 so that it has final velocity instead of initial. And you flip the positive to negative, but I think you only use this twice. And you hardly ever see it, so I debated on whether to include it or not. But overall, we talk about our kinematic variables, and what I tell folks is when you see these five kinematic variables, E sub f, B sub o, x, a, and t. When you see these guys, that should set off alarm bells. And I'll say, so we'll talk about your kinematic alarm bells. And so if you're stuck and we're working in class and I look at you and I say, okay, tell me what you have, and you start giving me these things, and I'm going to say, okay, what should you be able to do with those variables? Because those are your kinematic variables. So what we're going to do is we're going to spend the rest of the lessons actually applying this. The next one's going to be, what if we have an object on a surface? And then we're going to translate then what happens if we're going in a vertical direction and I'm actually falling, because acceleration when we're falling gets interesting. And we'll talk about that in a lot more detail later. But there's your four kinematic variables. So let's go to part 2 now so you can learn how to use them. And we'll carry on from there. Thanks for watching and have a good day.